So here's another comment that we should pay attention to. The sample mean and the sample proportion will improve in accuracy as estimators as the sample size increases. So there's two layers that help us explain this. The first one is mostly intuitive. We know that the larger the sample size that we have, the more information that we are able to use to really understand the true nature of the population. So we can expect that the sample mean or the sample proportion that we obtain from a larger sample is going to be to the closer to the corresponding population parameter. Now, in extreme cases, if we were to actually sample the whole population like we do in a census, the sample mean and the sample proportion will coincide with the population mean or proportion. However, conducting a census can be incredibly expensive, and so it's not really practical. So generally speaking, we look for sample sizes that are large enough to give us a degree of confidence that we can use when we're making our inferences. There's another layer that we can use to explain this idea, and it has to do with something that we've learned in a previous topic. Recall that the sampling distribution of the sample mean, x bar for example, is going to be centered at the population mean mu, and it has a standard deviation that depends on the sample size. So as the sample size increases, the sampling distribution is going to get less spread out. And that's what you see over here to the right with these two pictures. Up on top we have a sampling distribution with a relatively small sample size, and down below we have a sampling distribution where the sample size is larger. And because the sample size is larger, this standard deviation, or what we call the standard error, is getting smaller, which is making this second curve here much skinnier. And as a result, this is going to tell us then that the values of x bar that are based on a larger sample are going to be much more close to mu. So you can see most of them are going to be right in here compared to a sample size that's much larger. So let's do a quick summary. First, we're going to use p hat, the sample proportion, as our point estimator for p, our population proportion. This is an unbiased estimator. Its long-run distribution is going to be centered as p as long as the sample is random. Likewise, we're going to use x bar, the sample mean, to estimate mu, our population mean. It's also unbiased, and its long-run distribution is going to be centered at mu, as before, as long as the sample size is random. In both these cases, the larger the sample size, the more accurate the point estimator is going to be. So the larger the sample size that we have, the more likely it is that the sample mean is going to be close to the unknown population mean, and likewise for the sample proportion and population proportion. In conclusion, point estimation is relatively simple and intuitive, but it can also be problematic. Here's why. When we estimate, let's say, the population mean by the sample mean, it's almost guaranteed that we're going to make some kind of error. So if you just take some sample from some population, there's going to be error in that sample. And even though we know that values from the sample mean should fall very closely around mu in general, it's very unlikely that the value that we get for the sample mean is going to fall exactly at mu, the population mean. So given that errors like these are a basic fact of life for point estimates, then the estimates are in and of themselves basically given that these errors are a fact of life for point estimates, and of course they are simply because we're basing our estimate on just one sample that is a small fraction of the population. Given that fact, these estimates are in and of themselves of limited usefulness. However, if we could quantify the extent of the error that we're getting with our estimate, then they might become more useful. And so interval estimation is going to address this issue for us, and that's the subject of the next part and therefore the next video for this topic. So we'll see you in the next video, and we hope that this one was useful.